The last part of this example, how long does it take for block 2 to fall to the floor? So we're trying to find the time. And from what we know, again, the system's moving together, and the system is moving with constant acceleration. But be careful, because this acceleration is not equal to g. This is not free fall. Without forces, without going through that process, we don't know the value of the acceleration. So we won't be able to directly use one of our 3 kinematic equations for constant acceleration, but we have a workaround for that. We can use the definition of average velocity and relate that to find the time. So average velocity, way back in kinematics, we had said that the average velocity is 1/2 of the final velocity plus the initial velocity. And we also know that the average velocity is equal to distance over time. And so this is how we'll go about solving this. First of all, putting in a little bit more specifics. Our average velocity is 1/2. The final velocity, that's what we had calculated back on part A. I'm going to leave that as v for now, but it is going to be that whole expression. And then our initial velocity, it said it was released from rest. So v0 is 0. And so for our case, this average velocity is just 1/2 of the final velocity. And so that's what we're going to be able to set equal to distance over time. Let's clean this up a little bit. Let's solve this for time. So through a little rearranging, we're going to get that time is 2 times the distance divided by that final velocity. Well, the distance that our object moved was h, so 2h over, and now we have our whole answer from part A. That's square root of 2 m2 minus m1 gh over 1/2 big M plus m1 plus m2. Okay, and so that is an expression for the time. There is a little bit we can do to clean this up. First of all, we're basically dividing by a fraction, so we can think of changing this to be multiplying by the reciprocal. So I'm going to write this as 2h times the square root, and everything inside the square root I'm going to flip over. So 1/2 big M plus m1 plus m2 over 2 m2 minus m1 gh. And already that looks a little better. The other thing we can do is we can actually move this 2 back inside the square root. So to do that, make sure you do square that value, and then it'll simplify some of our coefficients we have. The simplified version of this is going to be h times the square root of big M plus 2 m1 plus 2 m2 divided by m2 minus m1 gh. So we see it kind of allowed us to clean up some of those coefficients.